Okay, now we're going to look at graphing a reflection over the line y equals x. I'm going to go ahead and do this one, just so that we know what it looks like. And this one isn't that difficult anyways. So here we have our x and y axes. I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So the first one, negative 1, 2. If we go negative 1 and 2, there's my f. And my g is at 1, 2. So f is negative 1, 2. G is 1, 2. So first we have to look at graphing this line right here, which I'm going to graph right now. Whoops. The line y equals x is the line where every x value and every y value is equal. So in this case, 0, 0 is a point on that line, 1, 1 is a point on that line because y equals x. 2, 2 is a point on that line, etc. So if I was to graph this, I'm just going to graph it with a dashed line, it would look something like that. Okay? That's the line y equals x. Again, negative 1 is a point, negative 2 is a point, negative 3 is a point. All of those are points on the line. Okay? Now, if I have the line FG, whoops, let's try that again. If I have the line FG, let's just do it in this color. And I want to graph over this line. The interesting thing is, all we need to do is flip-flop these. So if we're going from this point, if we're going from F, which is at negative 1, 2, and we want to go to F prime, all we need to do is flip-flop those two numbers. So this gives me 2, negative 1. And if we do 2, negative 1, this is my new F, which is at 2, negative 1. If I want to do my G, which is at 1, 2, I just flip-flop it, and I get G prime, which is 2, 1. Okay? So if we do that, that's 2, 1, that's right there. And if we graph that, that's a line that looks like this. Now, if you turn your head kind of to the side, ideally, if you do this right, you should be able to create a line that connects these two and a line that connects these two. And again, if you've done this right, and it's not very good on mine, but this should be perpendicular and this should be perpendicular. Unfortunately, in mine, those aren't perpendicular. But also the distance diagonally here and the distance diagonally here should be equal. So this distance should be equal to that distance. Okay? Let's look at it in their picture. It looks better on theirs. So here it is. Okay? And it's just like I showed you. If I was to draw a line connecting these two, hopefully you can see now, and connecting these two together, there's a couple things going on. First of all, these are perpendicular. And second of all, this distance and that distance should be the same, and these two distances should be the same. Okay? And again, what you would do is you would just flip-flop. Or what you can do is you can look and go, I'm going down 1 to meet it here, so I'm going over 1 here. I'm going down 3 to meet it here. I'd have to go over 3 to meet it over here. Okay? A couple different ways to look at it. and we're going to look at how do we know that that's perpendicular. We're going to find the slope of f prime and compare it to the slope of this. Remember, the slope of this, we're going up 1 over 1, so the slope here is 1. Okay, we want to show that this is a negative 1. Actually, we can just do it right now. I'm going down 1 to the right 1, so the slope of, and here as well, I'm going down 3 and over 3, so the slope here would be negative 3 over 3, which is negative 1. And if you look, these are opposite reciprocals, so therefore the two lines are perpendicular. Yeah, so the slope of GG should also be negative 1. If we go down, I don't know what they're saying. Oh, okay. If you go down a half and over a half, you hit the line y equals x, and then you can also go down and over again. Okay. Now we want to use this example for the line y equals negative x. I'm just going to show it to you this time, just to show you what it looks like, and we'll explain it. The coordinate rule for the other one, let me go back real quick. The coordinate rule for this one, by the way, would be x comma y becomes y comma x. So in other words, f, which was at negative 1, 2, becomes f prime, which was 2 comma negative 1. Okay? If we look at this one, when we do this, we're flipping it and we're changing the signs of everything. Okay? So the line y equals negative x is actually going to be a line that goes down diagonally this way rather than going up diagonally this way, because the slope is negative 1, the y-intercept is 0. So there's the coordinate rule. That means that f was originally negative 1, 2. When we flip these around and change the signs, this becomes negative 2, and this becomes positive 1. And g becomes, we flip them and we change the signs of both of those, so they both become negative, and it's negative 2, negative 1. So the graph looks like this. And again, if we look at this line, we can see that the slope of this is 1 and the slope of this is negative 1. The slope here, we're going up 3 and over 3, so the slope is 1. The slope there is negative 1. The distance from here to here is the same as the distance from here to here. We okay with that? I hope so. Ask about it if you have questions. So we want to prove that y is f prime is perpendicular to y equals negative x. So again, the slope here is negative 1, the slope here is 1. That makes them perpendicular. And finally, we have these points, and we want to graph them over both of these lines. Show you what both of them look like, and we'll go over what we would do in each case. So for the line y equals negative x, we would have a 1, 3 becomes a prime, and it's negative 3, negative 1. Okay, so here's 1, 3, and here is negative 3, negative 1. Because remember, again, in this case, it's x comma y becomes negative y, negative x. B, which is at 4, 4, becomes, b prime, which is negative 4, negative 4. And C, which was 3, 1, becomes C prime at negative 1, negative 3. And similar thing here, this time for y equals x, it's x comma y becomes y comma x. Oops. Therefore, A, which is at 1, 3, becomes 3, 1. B, which is 4, 4, stays at 4, 4. And C, which is 3, 1, becomes, whoops, this should be A prime, B prime, and C prime. This becomes 1, 3. If you notice, the 3, 1 becomes 1, 3, and the 1, 3 becomes 3, 1. So they reflect on each other. Okay? And I believe that's it. Thank you.